Similar to the method of discs, we have method of washers. Washer means something that has a hollow space in between. Now this is a circular cross section, but you can see a hollow space. So when we find the volume, we need only the volume of this space, not the hollow space. So what can you do? One thing is you can find entire volume and subtract the hollow volume. So how do we do it is very simple. Find the total outer radius. Using the outer radius, find the total volume. Okay, say this is 2, so radius will be 1 and solve it up. Then you can minus the volume of whatever is inside. Volume I I'll put because that's inside. But now we are not going to apply the formula separately and solve. We will just do it in the formula itself. I'll show you now. See, when you rotate along the x-axis, you get this washer. So what you do is pi r square is integration of pi r square is the volume. But over here, what we do is pi is out from integral wherever we want a to b. The outer radius square minus the inner radius square, we do it together. So we will get the volume of only the washer, not the hollow space. So r square, outer radius square minus inner radius square. Then we will remain with only the outer volume. Same way for y-axis, we just now saw y-axis problem. Even in the last lesson, we saw y-axis problem. What happens is everything will be with respect to y. And it's again the same, outer radius minus inner radius. We will see a problem now. Capital R is the outer radius, small r is the inner radius. Here we are getting, let R be the region bounded by the graphs of y equals 1 by 4x squared, comma x is equal to 0 and y is equal to 1. Compute the volume of the solid form by revolving R about the y-axis. This is important. It's along y-axis. First, we need to sketch the graph with our basic knowledge. Over here, you can see this is parabola. Parabola is something like this. Sorry, that is a very bad parabola. Now I'll draw, okay, parabola. Again, anyways, I hope you understand this is a parabola. But you are dealing only from x is equal to 0. So since there is no plus or minus, it will be at 0. This is at 0. So you're taking only this part. Okay, that's the reason. And they have told y is equal to 1. So where is 1? This is y-axis 1. Cut it over here. So only this region. Now look at this. If you rotate it along y-axis, do you get a washer? No, this is just like the previous video where we saw computing volume, the method of disks. So see, this is what we get. We did this in the last problem. So this is the thing. Now you know the formula for this. It is very simple. What is it? You need to get in terms of, you need to change this in terms of y. So get x to one side. We will change this. X square equals 4y. X is equal to root of 4y. And then limits. Where are the limits in the along the y-axis? It's from 0 to 1. So this is very simple. Substitute in the formula and get it. This is the previous formula. There is no change in this. Okay, but why we did this is we will see in the coming problems, that is B and C, how it changes. I hope this is clear. Over here, they have given us the curve, the function y is equal to quarter x square. And then they have given the limit of x is 0 and y is 1. So if x is 0, this is the point. Obviously, y also will be starting from 0. So the limit is 0 and the ending limit over here is 1. So this is the formula of the last topic of the disks. And this is how we get it. But now let's see the next type. Same question. Okay, the answer is 2 pi or 6.28 unit cube. In the last problem, I had written wrong, so I changed all the units in the whole presentation. I had an error in all of this. Sorry for that. The volume is always in cube, whereas the last lesson we were dealing with area, which is in power 2. Okay. So now we will move to the next same problem. So you can see this is the same problem, only it is rotated along x-axis. So here it is interesting. Look, here we need to sketch the graph, the same graph. There is no difference. The last problem, the same quarter x square. This is it. But what is the difference now? We are rotating it along x-axis. Last time we rotated along y-axis. It was easy. But now we will rotate along x-axis and we will get a washer. See, this is what is happening. Sorry. See now, over here, I just wanted to show you the difference. Same graph, but along y-axis. Now you can see this is being rotated along the y x-axis, and therefore we are getting washer. If the same graph was along y-axis, we will just get a regular disk. Now you can see over here, when we rotate this, we will get the top radius and the inner radius. We need to subtract this and we need to find only the wash area. See, now see, you need to understand. Don't think a washer is created just because we are like this. It's basically this cross section. Sorry, that's the wrong diagram. Wait, see this cross section over here, okay, but there is a hollow space that needs to be removed. So as we move along, the hollow space changes based on the function. Okay, so now if I'm drawing over here, this is the cross section, this is the entire cross section, but this is not there. See, because we need only this part, right? So this part and the down part, so the cross section we get is of a washer. So now the formula is different over here. Now we will try solving it up. Write the limits over here. This is very important. Sorry, radii and limits. What is the outer radius? Now we can see over here the outer radius from the x-axis, not the entire length. This is diameter. We need just the outer radius, the big radius from here to here. That is 1. It's given, right? We did the same thing. So then what do we do? Find the inner radius. So inner radius is basically this equation from here. Okay, it's just the equation. Now we have outer radius, inner radius, the small letter, and now we can find the limits. But how do we find the limit? We know it will start at 0, okay? We know it will start at 0, but where will it end? That is the important question. So we will equate these both, the touching point. See this point where we will just equate these both equation and solve, you will get the answer. Now in the graph, you can see this graph is drawn accurately, so we know, okay, this is 2. But what if you don't draw it accurately? Because you're not going to draw accurate graphs. You won't exactly know, okay, this is going towards 2. No, that's not going to happen. You will know only this value, 1, 0. How will you know this point where it touches the one line and this one where it touches exactly? That's why we need to find the intersection point, because you can't because no one, like, generally we will just draw rough graphs. We are not going to draw, see, it's a rough sketch of graph, not the exact graph. So you don't know this value. This value is found out by equating this line at 1 and this equation. Now you will get the intersecting point. So that intersecting point, quarter x square equals 1. When you solve it, take 4 to the other side, you'll get 4x square. Square root of 4. Whenever you take square root, remember it is plus or minus the answer. So it is plus or minus 2. Now apply, look at the graph. It has already been told for us that, see, this is 0. Okay, we got the intersecting point over here as 2. Okay, that is good. But can you take minus 2? No, we cannot take minus 2. Why? Because the limits have been stated from 0 over here to 1. Okay, this is the part of the graph. You can't go behind. So it is only from 0 to 2 along the x-axis. So the limits are along x-axis. Say x is 0 and 2. So you need to integrate along that axis now. So over here, limits along x-axis will be 0 to 2. Or x is greater than or equal to 0 but less than or equal to 2. Now we can see over here the same graph, but let's solve more. Step 3 is substituting and solving. Now, we know this is the formula, outer radius. What is the outer radius? It's 1. Inner radius, x squared by 4. And the limit from where to where? It's along x-axis. So x-axis, where is x-axis? The limits 0 to 2. We found, right? We found it in the last problem. So it's 0 to 2, 1 square minus quarter x squared the whole square. So this is it. Now we can apply it. You can put it in the calculator and solve it by using this symbol over here. Use this symbol, solve it up. You will get the answer. It's same. You can try it by yourself and check the answer. It'll be 8 by 5 pi. Now this is the answer. Volume 5.03 unit cube. I hope this is clear along y and x. And now let's do one last problem along 2. So now this is something interesting. Along y is equal to 2, line is 2. How do we do this? It's very simple. If you have understood the previous two problems, this is simple. If you have not, please pause the video, go back and then come to this problem. So the solution, as we know, by sketching the graph. Now the graph is the same thing. Look over here. This is the same graph over here, 1. And we found the intersecting point in the last problem, the B problem as 2. And now Y line, see this is the line. 2 over here you're rotating. So when you rotate it, what is going to happen? It's going to look something like this. See, this part is being rotated. So there is a big hollow space. Same like what we just now saw, inner radius and outer radiuses are formed. Outer radius would be from this, though, you need to consider. So it's a little bit tricky. What happens is whenever you have a certain line like this, whatever is the inner radius or the outer radius, you need to 2 minus that. Okay, wait, I will try to make it simple over here with the inner radius. It's easy to understand. So this is the inner radius of the circle, right? So this is the inside radius, as you can see when you rotate it. What is this point? It is 1. What is this over here? 2. So 2 minus 1. What is the radius actually? It is 1 unit. So this 2 minus 1. Same way, over here the outer radius is this function. 2 minus this function will give you the outer radius. So that is why we use whichever is this line. 2 minus the inner radius minus the outer radius. That is, say 2 minus 1/4 x square and 2 minus 1 equals 1. So this is how we get it. And the limits over here, we know we just now solved it 0 to 2. We have already solved it. The same method, we have just taken the limits. Now you can use the formula, substitute the formula for 0 to 2, but only difference is this radius. Outer radius is from here to here. Remember, it is 2 minus this equation. Okay, 2 minus the equation is 1/4 x squared, the whole square, and the inner radius is over here 1 at the point line 1, but it's 2 minus 1 because it's from the line y equals 2. That is how we can solve it. Put it in the calculator, get the answer, straightforward. So please remember the inner and the outer radiuses. So that is very crucial to solve this washer problems.